Unit 1, Lesson 4, Working out a logical sequence. Page 8, Exercise B. Listen to the interview about research and development projects and complete the notes. How do you plan a research and development project?
We often use a system called the critical path method, or CPM.
How does that work?
Well, all projects are broken down into steps and sequences. Certain steps have to be completed before we can move on to the next one, while other steps can be done simultaneously. So we work out a logical sequence. Using the critical path method, we can determine the minimum time we're going to need to complete the whole project.
So how does it work?
Well, we construct a diagram like this one here to show each step in the process and how long it will take to complete. For example, step A will take 2 weeks, step B 1 week, etc. Then we add up the total number of weeks of work to be completed. Once step A is finished, work can start on steps B, C and D all at the same time, though as you can see, step C will take longer to finish. We can determine the earliest completion date for project X by looking at all the possible paths through the diagram and finding the one that requires the most time. In this case, the longest path, that is, the critical path, will take a total of 10 weeks minimum from start to finish.
I see. So the critical path method helps you to establish a timescale for a project.
That's right, but a CPM diagram like this also gives us other useful information. For example, in project X, the earliest time we can begin step H is 8 weeks after the start. That is, once steps A, C and F have been finished. As we can see, step B only needs 1 week, and so it does not need to be started immediately in order to be finished on time. In other words, step B has a couple of weeks of slack time.
And how is this information useful?
It's useful because it allows us to allocate our resources more efficiently. We can keep the critical steps on schedule and, if necessary, postpone some of the slack steps without causing a delay to the whole project.
That way, the same people can work on different steps in the process.
Exactly, or the same equipment can be used for 2 different steps, for example. Of course, this diagram here is a very simple example just to give you an idea. In actual projects, the relationships between the different parts are often very complex, and a CPM diagram might cover a whole wall of my office.
But isn't it very time-consuming deciding on the sequence of the different tasks, estimating the time needed for each one, and drawing the diagrams?
Yes, it is time-consuming, but we find that it is a great aid to planning and control. Of course, the job has been made a lot easier in recent years by special computer programs that can do critical path and slack time calculations for us.